Thank you for joining us for our talk today. My name's Ken. I'm with Industrial Matrix. Today we'll be talking about condition-based lubrication. So what I'm going to do is take us through a little bit of a journey today from what we historically have done in time-based lubrication, the reasons why we shouldn't do that, and then as we look to move towards a condition-based lubrication approach. I'll just give a quick minute while everyone else settles in here, and then we'll get started. Come on down, gentlemen. We got front row down here. Fantastic. So to get started, I'm really glad that we have a chart of the uptime elements here today. Didn't have a chance to work that in my presentation, but I always like to start with that. I am a CRL for a number of years. So what I want to start is by highlighting what we're going to talk about today. So the environment that we're living in is this ACM domain here, and primarily we're going to be talking about ultrasonic testing as well as lubrication today and how those can help us towards achieving our reliability goals. As we get started, again, my name's Ken. Quick introduction to myself. I've been involved for condition monitoring a little bit over 10 years now. Spent some time as a millwright many years ago. And during that time, I've helped to establish reliability programs across a multitude of industries. Power generation, worked with oil and gas, pulp and paper, among others. As we look ahead, the technology, even in the past 5 years, has advanced to a point where it's allowing us to do things a lot more easily and streamlined compared to even how we did reliability maybe 10 years ago or even 5 years ago. And that really is a barrier to entry. The cost is starting to come down significantly. So there's a lot more tools available at our disposal this day and age, and that's going to allow us to get a better insight into the health of our machinery. So let's start with why we're here today. We're here primarily to talk about lubrication. Interesting statistic here, there's a lot of numbers out there online, but about 80% of all bearing failures can be attributed to poor lubrication. That number is drawn from SKF and Plant Engineering magazine there a couple of years ago. So why do we have bearings that fail? So primarily lubrication is the main culprit or the main source. Also insulation, wrong bearing, manufacturer defects. But what we really want to do is dial in our lubrication PMs to make sure that we're putting the right amount of grease into the bearing as it requires. We're not just blindly going out and following that work order that says pump it with 5 shots. Well, why do we do that? That's because the last guy did the work order and that's just our standard SOP. So we really want to move on to that next level. What I'll talk about today, some basic lubrication practices, history of lubrication, what bearings do. We'll talk a little bit about grease, condition-based lubrication. I'll get into ultrasonics because they are very important, probably the best tool available in industry today to help us accurately grease our bearings and get that feedback. And then from there, I'll show you a little bit of the equipment, the tools that are available in industry. There's a lot of different options. I'll briefly go over some of those. That way you're aware of what's available and what's out there. And then we'll wrap up with some questions and answers. So let's get started. Just by show of hands, I know we don't have clickers in the room. As a group in here, how many bearing failures or perhaps bearing issues, we can open it up a little bit more, have you had due to lubrication in the past year at your facility? So just by show of hands, 1 bearing, single, no lubrication issues. 2, what about 3+? Okay, there's our show of hands. So that's why we're all here today, right? Let's discover what we have available for us and what can make our lives easier for lubrication. So let's start by talking about lubrication practices. I want to back it up a little bit and talk about what lubrication is. So history of lubrication, what lubricants do, and then how much grease do we put into a bearing? That's the age-old question, right? As the conditions changed, and I'm going to loop it around with that first image I showed of a marathon because our needs do change depending on what we require. So brings me to my next point. How much water should you drink in a day? Well, experts say we should drink, 6 to 8 glasses of water in a day. But what if we're running a marathon, like these folks up in the picture here? Or what if we're in Florida and it's 90 degrees out with humidity? The point is, our needs change similar to that of a bearing. As our conditions change, as we run machinery harder in the summer compared to the winter, different environmental conditions, our consumption for lubrication goes up, sometimes exponentially. So much like the human body, we need to gauge that. We need to give that bearing the amount of lubrication it needs when it gets thirsty. And what is a way to really know that and accomplish our goals? So let's back it up a bit, talk about lubrication practices. Where did we start with lubrication? Well, way back in the 17th century BC, the Romans used stuff like olive oil and different types of animal fats to reduce friction. That's our ultimate goal. Reduce friction, reduce heat, allow us to have 2 surfaces that are in contact with one another to move more freely. So that's where we started. Then we moved into the 1850s, kind of that hit of the Industrial Revolution, where we moved into petroleum, and that became our industry standard. So as we look at where we are currently in industry, we have petroleum products, we have a lot of synthetics this day and age, but the point is we've always had lubrication in some way, shape, or form to dissipate heat and then reduce the frictional component between two materials. So as far as lubrication goes, what are lubricants designed to do? Why do we put animal fat underneath a chariot? Why do we grease axles back in the day? And why are we using petroleum-based lubricants today? Well, three primary objectives. We want to fight friction, we want to reduce heat, and we want to prevent corrosion, prevent wear in those metal parts and components. With grease, what is it comprised of? So when we talk about grease, we have a base oil, a thickener, and different additives. Different complexions depending on the application and what we're looking to do, but those are the three main components inside of any lubricant. So we talk about lubrication practices. So what are good practices? So we can start with our lube room. Just by show of hands here, how many people have looked at their lube room and started to really see what's going on in there? How are we storing lubricant? How are we doing our filtering? What's our contamination issues? I saw a couple laughs up here. What lube room, right? There's a barrel of grease out there and we just cart it around and put it in bearings and we go shove it back in the corner when we're done. So when we talk about lubrication, it really starts with proper storage and handling. Where is that lube being stored? How are we managing? It really is an asset in our plant. So how are we managing that asset before it makes its way into our machine? Then we move on from there. So obviously contamination is a big issue. We look at grease selection and then greases operating and doing really what they're designed to do. I've seen it time and time again where we put a standard lubricant in, but perhaps the bearing calls for a high temp, or we're not putting a lithium grease and we're putting, mixing greases can often give us more of a headache than really not putting the right amount of grease into that bearing to begin with. So we really need to start at good lubrication practices. So we move on. We've got the right grease, we've got good storage, good handling techniques. So what happens when we undergrease a bearing? Well, when we undergrease a bearing, we get that metal on metal contact. So we get those rollers, they make contact with the raceway. That generates heat. That also degrades our grease because now that grease is doing a lot more than what it was designed to do. We're making it operate outside of its parameters. When we overgrease, that can be almost as bad as undergreasing a bearing. So when we pack that cavity, I like to use the analogy, if you're out here in the resort in the swimming pool, if you're walking through about 2 foot of water, you can walk through there very, very easily. Now you go out in the ocean, you start walking through that water, maybe it's up to your shoulders, you have to work a lot harder to move through that water. The same thing with grease. When we overfill a bearing cavity, that bearing's got to fight a lot harder. We're going to increase our energy consumption, we're going to degrade our seals. Contamination can then become introduced into that bearing as those seals go out, and heat and wear on that bearing. So we want to find that sweet spot of lubrication. So what does our lube PM tell us? Well, we give it 6 pumps every 3 weeks. I've heard that one before. That's usually what the work order says, right? And maybe give it 5 pumps because we upped it a little bit due to under lubrication. But we really got to start to look another level forward. So what kind of grease gun are we using? Do we know what the output is? Have we calibrated that grease gun? What is 3 pumps? What is 6 pumps? Well, if we're using the Power Ryobi grease gun, that's 3 seconds of grease at 1,000 PSI, or are we just manually pumping? So these vary quite a bit. We really got to look at our practices. Are we using the same grease every time? What if you're not running as much? How about during the summer, the winter, temperatures rise, temperatures change? Does that work order, does that PM stay the same? Or are we modifying that depending on the seasonal, the demand of the machine, the output, and the wear? And then I always like to ask, where did that PM come from? Whenever I'm inside of a facility, we're looking at grease PMs. How much grease are we putting in that bearing? Well, we do 6 pumps every couple of weeks. Why? It's what the work order says. So we really got to start by questioning what our grease practices are and how we can optimize those and move to the next level. So next question is, can we ever be 100% confident that we're greasing a bearing just right? Are we under lubricating? Are we hitting that perfect zone of lubrication? And then how do we compensate for all of these factors? Because there's a lot of factors. Vibration, noise, temperature, they all affect how much lubricant we should be putting into a bearing. What are the consequences of not adding the proper amount? Well, I think we all kind of know that being here at a reliability conference. What does the L10 life of that bearing look like with improper greasing PMs? Are we hitting that 7, 8, 9, 10 years that we might get off that rolling element bearing? Or are we getting those failures? And then unexpected downtime is obviously the goal that we all want to accomplish. So making sure we're not having those failures as a result of lubrication. So that'll bring me to my next point. Do we have any way to verify this? How do we know what we're doing to that bearing is being done properly? What I've got up here is known as the Strybeck curve. So in tribology, it is the optimal lubrication zone of a bearing. So as we move from that boundary to that mixed film regime, that is when we hit that ideal lubrication quantity. And if you look at the graph here, that's where our frictional coefficient is at the lowest. As we move into over-lubrication, we move into that hydrodynamic lubrication. That's where we have too much grease. That film is not microns between the bearing. It really starts to increase. So if we know when we can get our frictional component at the lowest, what is the ideal quantity of grease? How do we measure this? How do we know that we're gonna hit that sweet spot? We're not gonna over-grease and we're not gonna under-grease on lubrication. Well, there's some calculators available online. This one is derived from SKF. We can start to look at the bearing. There's a formula if anyone wants to write that down. You just put that in your notebook. It's really easy to bang off, especially when you're at the machine. You can just kind of do some long math there. However, there's a lot of factors that affect how much grease goes into a bearing. So temperature, contamination, moisture, vibration, position, bearing design. There's a few more that probably aren't present here. So we can look at a calculator, we can look at the bearing, the OEM, but it still has us questioning how much grease do we put in a bearing? What is the optimal zone to lubricate that bearing so that we're cooling it and we're giving it enough of a frictional modifier that it doesn't act up on us? Well, that's where we move into the ability to add the right amount of grease. And this is where we start to introduce technology. What is available? What are the tools out there this day and age that allow us to optimally grease a bearing? Probably the best tool out there is ultrasound. Ultrasound is a technology that tells us how much grease to add and more importantly, when to stop lubricating a bearing. As we put grease in the bearing, ultrasound is going to give us that feedback on that frictional component. So I'll go over some of the equipment. There's a lot of different technology out there. If you guys have ever seen somebody with the earmuffs in the plant greasing down their bearing, that's one type of technology. There's a couple different options out there. But at the end of the day, what it's doing is measuring that frictional component. As we start to add small increments of grease, it's going to tell us when to cut off. A couple data sets up there as well. This is a bearing being greased in ultrasound, so you can actually tell it hits the bottom of that Strybeck curve, starts to go up, you're going to stop. Then another technology up at the top. That's where you're monitoring, baseline that bearing, it comes up in the lubrication zone, and then you can grease that bearing back down. So however it's deployed, it's a great technology to tell us when we over and under lubricate. So quick poll, who in the room has used ultrasound to grease bearings? Quick show of hands. Okay, so we've got a lot of guys here that have been exposed to it. Now with that, just a follow-up question, same group. Is that part of your current PMs? Have you deployed that technology? Is that alive and well in the plant? Perfect, see a lot of nods in there, which is great. We've got equipment out of the box, we're utilizing it. Do you also use your ultrasound to trend your bearing health? Do you get those scalers so you know when that bearing is moving into failure mode potentially? A lot of nods there as well. And then who's used ultrasound for any other application? Air leaks, steam traps, we can do electrical discharge with it, a lot of different applications out there. Okay, so it is a very versatile technology, not only for the lubrication side of things. And then Cat 1 is a good certification. Anyone in the room Cat 1 certified in ultrasound? Perfect, good show of hands as well. So we're getting more predominant with the technology as time goes on, which is great. So why ultrasound? Why is that the chosen technology? What's that going to give us that another technology won't for monitoring bearings? Well, ultrasound is very localized, just due to the nature of the sensor. When I stick an ultrasound sensor on a pillow block, it doesn't really care about what's going on further down the machine. It's a very high frequency, usually in around 30, 40 kilohertz. And what that means is if I had an ultrasound sensor right here on my podium, if that was a machine down there banging around in that high frequency bandwidth, the sensor's not going to pick that up. It's really focused on what's in front of it. I like to say about a 1 foot radius. So we know exactly what's in front of us. We're kind of blind to anything else outside of that. Also measures friction very well, very repeatable, consistent. And with some of the tools out there, you're able to hear the grease go into the bearing. Again, show of hands, the guys who are greasing with ultrasound, do you use the muffs? Have you heard that phenomenon where you put a little bit of grease in and it just kind of quiets everything down? It's great to hear. You know that you're doing something well to that bearing. With ultrasound as well, we can do a lot of other things. We can pair it with an auto luber for autonomous lubrication. We can do routes, condition monitoring. A lot of analysis can be paired with that. So let's go inside of a bearing. What happens When we walk out, if I were to have a portable collector, I stick my pickup on the bearing, got my grease gun, I'm ready to start greasing, put on my earmuffs. Well, one of three things are gonna happen. First thing is the dB levels go down. That's great, we're monitoring friction. I give it a shot of grease, I go from 40 down to 35. I'm doing well for that bearing. I'm reducing that frictional component. I'll keep greasing. Now, eventually, I'll hit that plateau in that Strybeck curve where those start to creep back up. That's where I'm moving into that over-lubricated status. At that point, I'll usually stop greasing because any more grease I add, I'm gonna start to pick up in my dB levels. So we kind of follow that stride, it goes down, we're gonna cut off that lubrication there. The other thing that can happen, the dB levels don't change. Now, that can be for a multitude of different reasons. If we're not putting in enough grease to change those frictional levels, a lot of other factors, if we have a grease line off, if that bearing's running dry on lubricant, bad lubrication PMs where we have to pack it up with grease to get that effective change. But one of three things will happen when we go. Usually we're gonna be going up or down if we're putting in the right amount of grease. That's gonna give us that verification. So where does ultrasound fit in? A lot of other technologies, it is very similar to vibration. I always say ultrasound can help us find a bad bearing, vibration can help us trend it to failure. That's how they kind of play off one another, that really early detection. So we're living in here, that stage 1 to stage 2 bearing failure, primarily stage 1, minor subsurface defects, we can usually grease that out of the bearing. If we were to leave that bearing long enough, heat, frictional resistance, we'll start to get some spalling, degradation, and then our vibration will pick it up. But that is really our first line of defense when it comes to rotating assets. It's also in the proactive domain as well. We show this time and time again, our classic PDF curve, but we put ultrasound to the left of that potential failure. And the reason is because we use it so predominantly for lubrication. Before that bearing develops a defect, the ultrasound is going to tell us. We can typically return it back to baseline with proper lubrication techniques. So like I said, it's typical to discover a defect with ultrasound, then trend to failure and vibration. I just want to point out here as well, we go from ultrasound, vibration techniques, and then heat. It's often been said, that bearing is running hot, let's get some grease in it. By the time you're putting grease in that bearing, when it's starting to run hot, you're already doing internal damage to that bearing. Your tolerances are starting to go, you're getting metal fatigue, you're probably contaminating the grease at that point. So really getting ahead of that failure curve is gonna save us a lot of time and ultimately a lot of downtime as a result. I just wanna talk about ultrasound basics as well. So where we go with ultrasound, just make sure we're good for time here. So a couple different sounds and frequencies in our environment. And I wanna talk about ultrasound specifically because it is so important and why it works as a good tool for us. So when we look at human hearing, we hear from about 20 hertz all the way up to 20 kilohertz. As we get older, that 20 kilohertz comes down a little bit. Anything before that is known as infrasound, and then anything above that 20 kilohertz frequency range is that ultrasonic domain. So we don't need to be super, super high frequency, but when we talk about an ultrasound sensor, we're usually in and around maybe 40 kilohertz, 30 to 40, depending on the OEM and the brand of ultrasonic sensor, so slightly above what we can hear. What does ultrasound do? Well, it's produced by the vibration of molecules. Different types of mediums, it can really travel. It's all around our environment in that high frequency band. We're just blind to it. Particularly solids is really what we're looking at with ultrasound, and we use the acronym FIT. So anything that produces friction, impacting, or turbulence is gonna put off an ultrasonic signature. In rolling element bearings, we're primarily focused on the frictional component, but we start to get some impacting as well. As that bearing runs dry, it can start to bang around in there and really give us some feedback. Again, a whole myriad of other different applications as well that we use for the technology. So when we talk about the sound wave, and this just builds on why ultrasound is such a good tool because it is so localized for lubrication. So as the amplitude increases or decreases with distance, we look at our wavelength. So lower frequencies, we're gonna have a lower wavelength. As we move up in that frequency band, those waves come a lot closer together. I'll show you a chart in the next slide. As we talk about that ultrasonic, that high frequency range, I'm just gonna skim forward here and find my chart. The wavelength at around, my frequency of voice, I'm probably talking around 100 hertz. It's gonna be feet or at least, quite a few inches. As we move up into that high frequency band, specifically ultrasound, that wavelength comes a lot closer together. And the reason why we use that tool is because higher frequency wavelengths are much more localized. So we're not, again, picking up what's going on further down the machine. A good analogy I like to use is if you're in another room, say they're having their party over in the main room right now, they've got the speakers on. You can hear that bass. That wavelength is going to travel very far. The boom, 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 boom. The higher frequencies, not so much. They'll get cut off. So as they hit a barrier, they don't travel very far. That's the reason we want to use that type of technology to really narrow in on our bearing. We measure sound in hertz. In North America, we also use CPM. And the higher the frequency, the shorter the wavelength. So again, I talked about it before. We're in around 30, 40 kilohertz. So that wavelength is only about half an inch, if not shorter, in that ultrasonic domain. My voice is about 100 hertz, so as I speak, I propagate a much longer signal. That's why if I yell louder, I've been told to yell, you can hear me from the other side of the room. If I were in the ultrasonic range, you probably wouldn't hear me very well, even if you could hear in that high frequency pitch. So just to summarize, ultrasound measures friction in a rolling element bearing. We use a very high frequency to do that, meaning the sound's very localized and it does not detect events very far away very well. It can tell us when exactly to grease a bearing by measuring that frictional component and change when grease is at it, and really help us to indicate over or under lubrication. So that's giving us the water that we need. Again, giving us what we need when we need it, much like a marathon runner. So I know I'm a little bit ahead of schedule. We can open it up for questions here. I'm just going to finish off by talking a little bit about some of the equipment that's available out there, because it's great to have technology, but how do we actually look at what we can bring in and make our facility a little bit better? So a couple different types of equipment out there for ultrasonic monitoring. I kind of put up a whole myriad of screenshots here, a lot of different manufacturers, OEMs, available options out there. So we start with some handheld basic tools. They're great for off-route ultrasound. Typically what you can do is strap it on a grease gun. You'll have a set of earmuffs. You can listen to that bearing, give it to your technician. They can go out. Takes them a couple minutes to learn it, and they're already greasing acoustically, getting that feedback. Moving to some more advanced stuff. So some of the detectors, we can map out a route. We can put in a database. We can monitor, trend that bearing. We can do a little bit of analysis as well. And then we move into online systems where we can grease a bearing manually, we can grease it automatically. So a lot of different technology out there. I'll go over a little bit of what each one does and the benefits for you as well. So when we talk about basic ultrasound equipment, it works primarily off-route. Again, there's no history. You don't need to know the bearing. You don't need to have a database of any sorts. You can just give it to your tech, tell them to, give them the crash course. Where do you put that sensor? How do you listen to that bearing? And then he can start greasing that bearing right from day one, or she. And as they listen to that bearing, as it sucks in that grease, then they can move on to the next one. Nice and quick, easy to deploy right out of the box. We move into some of the more advanced stuff. A couple different manufacturers out there. This typically works with a software package. So it's gonna allow you to pre-program what bearing you're on. You can put your quantities. More importantly, you can trend that bearing. So as you go out, take your ultrasound measurement, lubricate that bearing. That's gonna allow you to take that data, download it, put it back. Now you're doing some condition monitoring in addition to your lubrication. With that, you can do some analysis as well, reports, all that fun stuff. And then the next generation of equipment that we're getting into is online systems. So online is definitely all the rage, putting a system out there, deploying it a little bit more hands-off. Some of the benefits, it's gonna provide you with real-time monitoring. So you know exactly the health of that bearing 24/7. And you also know when it's time to grease. Now, a lot of these start to pair up with auto lubers as well, so that bearing's continuously monitoring. As you hit that threshold, your luber's gonna fire grease that bearing, settle it back down to baseline. It's a great technology for equipment that's out of the way. Lube PMs are potentially missed, sometimes if you ever remote it out, or if you've historically installed auto lubers on equipment and just kind of set it and forget it. I've heard the horror stories. Yeah, we set that up 3 years ago. Well, what's happening with it? We don't really know. The batteries are dying. So just to go over a little bit of some of the equipment there. I know quick presentation, kind of ran through that material. Just as we wrap up, I guess I'll open it up for any questions and answers on the floor here. Anyone have any questions? Anyone have any comments about their experience with greasing bearings with ultrasound? Go ahead in the back there.
Sounded like a great idea, and then we found out that a whole bunch of the techs were from these 30-year-old guys following the 100-year-old guidance.
Yeah.
Pack it up until it comes out the other side. Well, when you start doing precision greasing and the sound never changes, they always think, well, I'll just keep going.
Just keep going.
So we stopped trying to do that until we could get our hands around, stop doing that other crap.
Right.
We only need to grease that once a year on that motor. So
That's it. And often the strategy is, sometimes overpacking slow rotating bearings that are crawling, that could be a lubrication strategy. But for 90% of your equipment, usually it's probably already in that overlube state. And that comes by way of, your mechanic's gonna go out there, and what's he normally gonna do? Pump until that gun can't go anymore. I can feel resistance, that bearing's full, I'm gonna move on to the next one. So yeah, doing stuff like, getting a good baseline established is definitely critical, especially knowing where you are. If you know that that bearing is running at 40 decibels and that's your optimal zone, then that's always gonna be your target. And often, with the portables, they can come out and check it, and part of the work order, the PM can say, this bearing is running, at or below 40, do not put any grease in today, because we're just gonna over lubricate that, and we know that. So great point there to make. Any other questions? Anyone else have any experience? Some of the guys that put their hands up, the grease ultrasonically, some of the experience that they've had with the technology in their facilities. I can look at Jim. Jim's always got a story to tell.
These stories, you got the fullest of the rooms that I've had so far, Ken, so there's got to be a lot of questions swimming around here.
And the quickest presentation, it's like PMs, I'm just optimizing time here. Absolutely.
Grease hardening or solidifying storage with the oil lube, is that an issue?
So what you're typically gonna wanna do is you will clean that bearing out ahead of time to make sure that you don't have any buildup in there, or make sure that it's got a relief valve installed on it. That's always important. The good thing about ultrasound though, is even if you don't do that, if you put your sensor on that bearing, say with an auto luber, you go to start greasing that bearing. If there's no reaction, then you're gonna cut off your greasing and say, okay, why aren't we getting that feedback that we want? Do we have old hardened grease in that bearing? Is it not penetrating? So that's where the technology really starts to give you that feedback, so you know exactly what's going on. But yeah, that's a great question. Have you used ultrasound for lubrication?
We have what our building department do, I'm an electrician.
Okay.
It got to the point we had to have one department do it because different people weren't doing it, so we just had one department do it. I have ultrasound training, but they do it.
Okay. Do the electricians grease the motors in your facility?
No, we have a lot of techs that do that.
They do that? Okay. And that's often, it's good to have, one source that will do lubrication, because if not, those grease guns tend to get grabbed, that's.
People using different kinds of grease, and those are other issues as well.
Exactly.
It still has some over grease.
Absolutely. And lubrication is often one of those things that's, who does the lubrication? Sometimes, or historically, it's been the low man on the totem pole. Here, you've been here 25 years, you take the nice job, here's the grease gun, go wander around and grease bearings all day. But the effect in the implementation, the effect on reliability throughout a facility, if you're not doing that time and time again, it might not happen tomorrow or next month or next year, but eventually it will start to bite you as your downtime piles up. That's a great point. Any more questions? Yeah.
You mentioned off routes in your presentation. What's the context of that?
So off route would imply just a simple portable handheld instrument. So you don't need to get into a software package, you don't need to design it. It's just simply something you can take with you and go. There's a lot of great tools out there, a lot of good manufacturers. It's usually a good way to start as well, if you want to get into the ultrasonic greasing, and then you can kind of graduate perhaps on some more of the sophisticated stuff. But at least you have that tool, that tech can listen to that bearing as they put the grease in. Usually it ties into the grease gun as well. Where do we go? Just to give you a visual. So a lot of them have lubrication adapters where they can just stick their Zerk fitting right on it, and then they're listening to that bearing. So they can go portable with it. Yeah.
Could you paint a picture for what a good lube room looks like and what one that maybe doesn't? We don't have one, and so I'm wondering just some best practices of how to maintain that kind of room so I can envision what it might look like.
And make it, yeah. And it's a shame, I had a picture, but I kind of cut down. I wanted to make sure that I was on time with the content, which I went very early on. A good lube room is clean. It's stored properly, labeled. Things like putting a color code band on your grease gun, so you know that this gun has our mobile polyrex, or this has our, whatever type of grease you're using in there. Organization. It's the old adage, if you walk in a room and go, man, this is kind of a mess, then it's really a case to start to improve your lube room and your lubrication practices.
So how do you keep it clean with all the grease?
Organized.
Does it
just from getting grease all over. I mean, good housekeeping is obviously one of them, but if you start with labeling and organization, I mean, a little bit of grease here or there doesn't hurt. It's just knowing what is where. Having a clean room as well. You know, if you walk up to your oil drum and it's covered in dust and all types of, you know, atmospheric particles that are there, that's eventually going to make its way into your bearing. And then what happens when you go out and you grease that bearing, you're just putting all that sediment in there. And again, it won't happen overnight, maybe not in a month or a couple weeks, but that will start to degrade the metal in your bearing and ultimately lead to wear. So, you know.
I had a question that was kind of on that, and I did see a hand go up. Sorry, I'll be quick. So one of the comments on open things and whatnot, do you recommend filtering oil when it arrives in the plant, or do you, any comments on that?
That's usually good practice. I'm not going to talk specifically about lubrication storage. That I would not say is my expertise, but historically, filtering oil out when it comes into the plant would be a good SOP as far as your lube room and keeping that organized as well.
To complement the idea, it's always better to have the lubrication, the storage, indoor and outdoor because of the sun and all that. But sometimes indoor is too dusty.
Mm-hmm.
So not an inexpensive way to solve that, but it's a really good one, is a sea container. Like those ones that you use on the cargo, on the ship. You have that one and you turn that into a room, and you do a really good work on the insulation part, or isolation part, and that's a really good way to keep the dust away from your storage.
Absolutely. Having that dedicated area where sometimes it is hard to find, but not having just drums of lube out there, production floor, kind of dusting up. Yeah, go ahead.
So what he said to temperature control is oftentimes important with not having big changes in temperature control, which can induce moisture and things as far as oil
Absolutely.
storage.
Absolutely. I know in a perfect world, we would all have that clean lab environment that you would see, you know, in the pictures online. Realistically, that's never going to be plausible. But really starting just to look at, okay, where do we have available space? Where can we put this grease in an area that, and it's not going to be susceptible to that degradation within the plant. So Jim, go ahead.
For the lube rooms, keeping them clean, also positive pressure for that room, so it keeps the dust pushed out instead of sucking in. And then, you know, temperature controls, desiccant breathers, storing your drums on the sides, 3 and 9. When you get oil, you can get it stored. If you have filled containers with a filter on it, pump it in there, and then they agitate and stuff like that. Otherwise, get a desiccant breather and store it. And then as you use it, get filter carts and filter it before you use it. Don't leave anything open, it exposes it to oxidation. And then we're talking particulates that are basically you can barely see with your eye or less. That's what we're looking to keep the oil wedge clean
Absolutely.
for the bearings, for the grease.
I've got to say, Jim's plants have the cleanest lube rooms that I've seen out there. Most of them. Some of them. Go ahead.
When you're talking about auto lubers, were you talking about the smart lubers that the sensor activates the smart luber when it goes below a certain decibel level?
Exactly. Typically above a certain decibel level. So in the continuous type of systems that are becoming more predominant, you're monitoring that bearing, you know, sampling every 5 minutes, every minute, every 10, depending on the parameters. And as that bearing in real time starts to become dry, so you get that metal on metal contact, that oil works its way out of the raceway of the bearing. That bearing's gonna get louder acoustically. That's where your auto luber can take over, grease that bearing back down, and then give you that feedback as well. So
Also,
good.
when you're talking about the lubrication, I think the best way to start is consolidate, make sure you have compatible greases and you're not incompatible and make a mistake.
Exactly. I think we've all seen, at some way, shape, or form, a motor taken apart and a different rainbow of grease in there because, you know, a grease gun's a grease gun. What does it matter? Just put the grease in. Yeah, go ahead.
Yeah, to add on to the lubrication housekeeping, we found that having a lube room specific PM, whether it be monthly or whatever, we kind of adjust depending on, our intervals and whatnot, but it's a good time to fill our oil storages. It gives technicians time to filter new drums that have come in, and it gives you a chance to clean your lube room, make sure everything's ready to go for the next technician that might possibly need it. So we found having a
Absolutely.
hole actually really does help with.
Is that like a monthly get in, go through the lube room? Absolutely.
Or it's sometimes too on any additional downtime, it's productive to go and just kind of, check in on the lube room, make sure we're good, make sure our lubrication stickers that we stock in there are all in stock and nothing needs to be ordered, that kind of thing.
Absolutely. And as you know, we all get busy, right? So stuff like that tends to take a back seat until it doesn't anymore. And that's usually when we're having issues and starting to root cause, trace it back. Some of the best tools in industry, probably the cheapest reliability tool that you'll ever buy, they cost about 2 cents. Those little Zerk fitting caps, if you don't have those in your plant, those can save you thousands of dollars just by putting those on. Because if you walk out, if you're not cleaning that bearing or not using, a particle-free cloth, that's all going in the bearing when you grease it as well. So you store it, get it in the bearing properly. That's going to save you a lot of headache in the long run. So we had a hand. Good.
On the next level, besides using the ultrasound, we've got automatic systems. I know you can't really talk about them.
No, I know nothing about it.
And we've been piloting them for the last year or so. We've had really good results, a lot of good findings. We're using them on our criticals, so we've got some extruders that are 600 and 700 horsepower. They're critical. Obviously, on the larger motors, you have 2 different bearings between your inboard and outboard. Unless you're trained and understand that, you can do the calculations, but unless you do the calculations with the right bearing and all that stuff. So the ultrasound is good. We're finding that we're under greasing a lot of the bigger motors. We've had some repairs from the motor shop that were identified that actually didn't have the fill tubing go to the bearing because the bearing wasn't put in correctly. So we've had some really good findings. And then what we're also doing is putting them in areas where they're just crappy areas. As a maintenance guy, you don't want to send somebody in there. They got to climb a ladder. They got to go in, turn the machine off, climb a ladder. You got open belts for pulpers and things like that. So we're actually monitoring our bearings on our most critical stuff with the auto lubers that Industrial Matrix says. And we've had good luck. And
Absolutely.
What auto lubers are you using?
the Industrial Matrix, so they're a perma with an ultrasound sensor on it. They also have the capability of doing vibration as well. So.
Absolutely. And
Maybe you can talk to the difference between condition-based and route-based and what the value streams are, like maybe elaborate on Jim's point.
yeah, absolutely. So, one case example, started working with Jim a number of years ago, and we had some of his most critical 100 horsepower motors, if not bigger, 600, that's right, big extruder motors. And as we started to dial in these motors, what we discovered was in the motor, the non-drive end bearing, it was taking grease properly. The lube PMs were fairly dialed in. However, the drive end bearing on this motor, it took a lot of grease to enact a change. So what we did is we started to dive in and we looked at the lube PMs. Well, the lube PM called for the same amount in both bearings. However, in this motor, the front bearing, as Jim calls it, was a big dinner plate. Tail end bearing was a lot smaller. So it probably took about 2/3 of the grease of the drive end bearing. What we discovered over time using a condition-based approach is that for the entire life of these motors, when they switch them out every 7-8 years when they do an overhaul, they're under-greasing the drive end bearing, which is really important. So that lube PM that it was calling for, maybe it was dialed up for one of the bearings, but that one bearing was still starved for grease. They were never really scratching the surface on it. To add to Stephen's point, the advantages between doing something like a continuous or a route-based, it all comes down to cost and effectiveness, right? So if you have areas that are hard to reach, the technology has gotten to a point where maybe you don't need a manpower on that particular asset, that particular machine. It also allows you to grease that bearing instantaneously. So if you're running a 1-month round with your portable ultrasound instrument and you're greasing that bearing down by 20 dB, when you move into an online type of monitoring, it's giving that bearing the grease more or less the moment that it needs it. Goes up, breaches threshold, you're greasing in real time to get back down. So you're not getting that 3-4 weeks of wear that you could plausibly get with a portable instrument.